Okay, I'm going to show you how to use the power rule for taking the derivative of a function. So as you would be studying in your calculus class, the derivative function allows you to calculate the rate of change at any specific point for your function in question. So when you're using the power rule, here's the general idea up here. So it has a lot to do with the exponent. So if you have x to exponent n, looks to me that when you take the derivative, which is indicated as y prime here, you're multiplying this exponent with the constant, whatever it might be, in front of the x, and then you're lowering that exponent by 1. So again, looking at this example here, y equals x to the cubed. If I apply that principle, the power rule, I'm going to go 3 times that 1 in front, and I'm going to decrease that exponent by 1. So that would be my derivative function, which would allow me to find the rate of change at any specific point for that function. Now, usually we indicate it as y prime. We could also use an indication of dy dx, which stands for the derivative with respect to x. Either one of those are acceptable. So again, it might not be a 1 in front. Here you've got 4x9, so 4 times 9, going to give you 36. And we're going to decrease that exponent by 1. Now here I've got a constant. Now when you take the derivative of any constant without that x variable, it's always going to be 0. Now I can prove that because I could also write that as 7x to the 0. That would be equivalent to 7 because x to the 0 is just 1. So when you go 0 times the 7, that's going to give you 0 and wipe everything else out. So the derivative of any constant, it's kind of nice to remember, is going to be 0. Now this case right here, where you've got x to the 4 in the denominator, I can rewrite that as a negative exponent, so I could bring that up, and it'd be 4x to the negative 4, and then I could apply my power rule. Negative 4 times 4, negative 16. Now just being careful, when I decrease negative 4 by 1, it's going to be negative 5. And then of course I could rewrite that as a positive exponent, bringing it back down to the denominator. So also, if you have a function with a series of eligible power rule functions, all you're going to do is you're going to take the individual derivatives. So 3 times 2, decrease by 1, 9 times 7, decrease by 1, and rid of the constant 12 is just 0. So again, that's how you're going to use the power rule. Now the power rule is going to come up in all the other rules we're going to discuss in this series of taking derivative videos. See you in the next one.